Yeah, screen should be visible now. Oh, okay. So accidentally on the first chapter. Let me scroll down. So we were at APs. All right. So today we'll do GP. Yeah, that was the plan. And for GP, you just need to know a few things. The first one is, all right. So we did a few sums as well. Okay. Before GP, we need to talk about something relating to AP as well. So arithmetic mean, right? So what is arithmetic mean? All right. Why do we call arithmetic mean arithmetic mean? We could have called it anything else, right? Why? I mean, why that name? Why arithmetic? Why not something else? Yes, anyone? Do you know any other type of mean? We did this last day. Yes, anyone? You have,
It's
you have,
called
yes,
arithmetic mean because it is part of the arithmetic progression and it's like the average of.
yes. So average is correct, but how do you relate average to arithmetic mean? Because you can take an average of anything, right? I can take an average of 1 and 1000. Does that mean that they
Because
are in
the
AP
average would also be in an AP
with?
with the numbers that we are taking the average. If I take the average of A and B that are in AP, then the arithmetic mean would be like that arithmetic mean that we get would be an AP with A and B. It will form a arithmetic progression, the three of the numbers. If we take two numbers with a common
What if we take the average of three values?
three values,
Then
that won't exactly be an AP because we are trying to find like the average of when we find AP, we try to find the middle value of two numbers and
correct.
we make a progression like that between two numbers. That
Ye-
won't be possible if we take three.
Yes, yes. Good. So I hope others understood as well. So if we are taking the mean of three numbers, that is why we sometimes drop the mean and go for just average. Okay. We call it simple average. All right. Because there are moving averages also, or weighted average. Those are different things used mostly in commercial mathematics. But for now, we know that if we take the arithmetic mean of two numbers or average of two numbers or whatever you may call it, you call it simple average, mean, whatever you call it, that number will be such. If it is x between a and b, then a, x and b will be in AP. Okay. Now how do you get that entire if you want to get arithmetic means for three numbers, how would you get them? You would pair them twice. So if you are trying to find out the arithmetic mean for a set of numbers a, b and c, you would go for something between a and b, get the arithmetic mean, and something between b and c, get the arithmetic mean. Okay. Of course, all of these numbers will be in AP only if a, b, c were originally in AP. If a and b are in AP and c is a random number, then obviously those three numbers will not be in AP. Okay. Understood? So arithmetic mean is quite important just because it is one of the simplest averages. All right. If three numbers in AP are in AP, then the middle one is called the arithmetic mean. All right. So basically, if you have, let us write it down. Now, this is also important because you can use this to actually find out if numbers are in AP. All right. So if A, B, C are in AP, I think we use this just here in one of the previous sums. Then A plus C by 2 should be equal to B. Okay. Not only is this the definition of arithmetic mean, but also you can use it as a necessary and sufficient condition to prove some numbers are in AP. Okay. So if you have to prove something is in AP, you can show that the middle number is the arithmetic mean of the other two. If you can show that, that means they are in AP. All right. So it can be used in two ways. All right. Now, there is a formula in which we try to insert a few arithmetic means. All right. So let's say I want you to find, it can be treated as a question or it can be treated as a separate theory. So let us do this. Insert n arithmetic means between A and B. Try, see if you can figure this out. So if there are more than one arithmetic means between two numbers, what does that mean? Let's say n is equal to 2. All right. Just for a moment, assume that n is 2. So that means you will have two numbers. Let's call them n1 and n2. So that means A, n1, n2, and B. All these four numbers will be in AP. Okay. Just as an example. If you take A and n2, n1 will be in the middle. If you take n1 and B, n2 will be in the middle. All right. Hopefully it is clear. So how will you write this formula or the derivation? This is what I wanted to say as an example. I'll illustrate it as well. So if you have A, N1, N2, and B, so this N1 should be the arithmetic mean of these two, and this N2 should be the arithmetic mean of these two. Okay, so this is in the middle of these two, and this is in the middle of these two. That is how you can insert n of these inside. So it should go to n of n, right? So n, n1, n2, and so on. So the properties will still continue. If I have n3 here, a n1 will lie between a and n2, n2 will lie between n1 and n3, n3 will lie between n2 and b, and so on. Learn this concept because this will be very useful when we learn about definite integrals and Riemann integrals. Okay, there we will slice the interval into thin strips of rectangles. You will need this. Try it.
In this case, do we have to derive the formula that the common difference equals to b minus a by n plus 1?
Good.
Oh,
Continue. Give me the formula for t of n plus 1. Others, I hope you are following. If you have any confusion, do ask me. But first, one of you should be able to complete the sum. Then I'll clear it up.
here, like if I'm trying to insert n numbers, arithmetic means between a and b, is then b would be the n plus 2 term. Then
Yes,
I can write b equals to a plus n plus 2 minus 1 into d, and from there I'm getting the value of d.
correct. Correct. So, others, hopefully you followed it. So, A, there are n things here, right? N means and then you have b, right? So total terms will be equal to n plus 1. That is clear, right? Sorry, total terms will be equal to n plus 2. Now let me shift this down. So total terms will be equal to n plus 2 here. So now b is the last term, right? So b will be equal to a plus, this should be n minus 1, but there is a total of n plus 2 terms. So this will be n plus 2 minus 1 into d. Right? From here you can calculate d. D is going to be b minus a by n plus 1. All right. Now what will be the formula for any random term? T of n plus 1. T of n plus 1 should be a plus p minus a into, no. What will be t of n? So what is t? Okay, t1 is a, right? And t2 is a plus d. So t3 is, okay, so this is just one less, right? So it will be a plus n into d. D is b minus a by n plus 1. Is this formula clear? Everyone? Yeah, too blue. Wait. Fine. Everyone noted the formula, understood how we got it? If you have understood it, then do a sum. Let me give it to you. So it says insert six arithmetic means between 3 and 24. Right. Hopefully you have understood the derivation. Okay. There was nothing complicated here.
Is it 6, 9, 12, 15, 18, 21? As in the common difference is 3.
Common
Yes,
difference
sir.
is
Common
3.
difference.
6 arithmetic means between 3 and 24. 3 and
Common
24.
difference is 3.
Yes. And where did you start with?
6, 9, 12, 15, 18, 21. These are the 6 arithmetic
Yes.
means.
Yes. Fine. 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 All right. Well done. Others? All clear? So you can do this by calculating the common difference, right? I hope that is implied. So calculate the common difference. D is equal to b minus a, 24 minus 3 by how many? 6 needed, right? 6 plus 1. So this is 21 by 7 is equal to 3. So the AMs will be it'll be common difference 3 starting from 3. So it will be 6, 9, 12, 15, 18, 21. Done. All right. Now this is obviously not the entire syllabus of or the entire scope of AMs. We will do more sums on AMs when we pair it with GMs. All right. So let us continue. Let us learn geometric progression. Okay. Now someone has to define geometric progression. Tell me what it is. You don't need to give me the definition from the book. Just tell me what you understand.
স্যার এখানে কমন ডিফারেন্সটাকে ওখানে কমন রেশিও।
হ্যাঁ, সেটা তো একদম বুঝলাম, ঠিকই বলেছো। আর একটু এক্সপ্যান্ড করে বলতে হবে, ওইটুকু বললে হবে নাকি?
Sir, like between any two consecutive terms, if we take the ratio, that will be constant throughout the series.
Fine, but you missed one important point. The what was the important point she missed? Anyone? The definition was absolutely correct. The definition of common ratio was correct. The structure was correct. One term was missed, and that is you should start from a non-zero initial value. Okay, otherwise all the ratios will be zero, right? So ar square, ar cube, and so on, that is fine, but a should be non-zero, otherwise you'll get zeros everywhere. That that does not make sense, right? Because if you try to calculate the ratio in a set of zeros, you will have to do 0 by 0, which is again a problem. So a geometric progression is a sequence of numbers whose first term is non-zero, and every other term is obtained by multiplying the preceding term with a constant quantity. That constant quantity is called common ratio. Agree, all of you? Understood? Definitions are such that if you miss one simple phrase, it will be a problem. Okay, so I was not looking for this exact definition. I just wanted to see whether you know all of the components of the definition or not. Okay, so geometry progression is that. And how will you write the terms of a GP? Well, again, it's very easy. You just so this geometric progression is going to be written as ar square, and so on. So here r is the common ratio. R could be 0. A should not be 0. Okay, if r is 0, then you will still have the first term, right? And then everything will be 0, and a is the first term.
But then, sir, first term is A,
Huh.
second term is AR. But then third term, once it becomes zero, then
Huh.
0 by 0 it becomes not defined, right? The ratio.
Yes, but you have already defined the ratio to be 0, right? So you do not need to redefine the ratio. Okay, you are
Okay.
starting with r equal to 0. R is known to you already.
Okay.
Okay, if you already know it, you will not rewrite it, right? So that is how it works. All right, so ar square, r common ratio, a first term, a non-zero. Fine, we will notice a few cases now. What happens if r equal to 1?
All terms are
The
equal.
sequence is the same.
So constant sequence. What happens if r equal to 1 minus 1?
Negative constant.
No. Think.
Or is it?
Think what happens if a
Oh, the
equal to
signs
5?
alternate.
Yes, and that is called, there is a specific term for it. You have learned it in physics. Starts with O.
Oscillating.
Yes.
Oscillating.
Okay. So this is oscillating. All right. All right. Now what else? General term of a GP. Okay, we know general term of a GP. What is the general term? General term is Tn equal to AR to the power n minus 1. Why n minus 1? Because the first term is A, right? So it will take a bit to catch up. All right. Next. All right. Do a sum. Try. Should be very easy.
Three
If it is 3, then the third term will be 9 and the fifth term will be
minus
81.
okay, it can be minus three also.
Can be
Plus
minus.
minus three.
So
R I'm getting R square is 9, so
yeah,
R can be plus
plus minus 3. Yeah, because then the first term will be 1, second term will be minus 3, then 9, minus 27, and 81. Yeah, it will work in both cases. Plus minus 3 is correct. All of you got the same answer? So here you will get R equal to plus minus 3. Okay, if you are satisfied with the problem, there are no doubts, then we can move on to the next bit of theory, which is sum of a GP. Now, sum of a GP is divided into two parts. Anyone remembers the formula?
A into R raised to n minus 1 divided by R minus 1
Correct. Go on for
for R greater than 1.
yes.
An for R equal to 1.
Once again.
An for
Yeah, you
R
don't need that. That is a simple case. Go to the other case, important one.
A into R 1 minus
Hmm.
R raised to n
Hmm.
divided by 1 minus R less than 1.
Fine. Fine. So these are the two formula for the sum of GP. Okay. R equal to 1, I'm not doing because that case is for children. Okay. You just have to add n things to it. Now, what happens if if n goes to infinity? Then
then the formula would be A by 1 minus R.
and in the other case,
Plus, um,
Sir, it only works if R is less than 1.
fine. So this will be DNE, R greater than 1, and A by 1 minus R for R less than 1. Can you show how this formula is obtained? This one? How do you obtain this from that? Try proving.
Sir, when n tends towards infinity, 1 minus r power n goes closer towards 0.
No, then everything would be 0, right? Because you're multiplying 0 in the numerator.
Sir, since raised to n, since R is less than 1, it is 1 by R, and as its power is going to infinity, it will become 0. So 1 minus 0 is 1, and A into 1.
Yeah, fine. So if R is less than 1, it will be a fraction, right? We are not talking about negatives, okay? Because negatives are in our oscillating sequence. They will be added differently, all right? So forget about that. Consider it about just the positive part. So if R is less than 1 and R is positive, then R has to be a fraction, right? If R is a fraction and you keep raising, okay, by fraction I mean you can write it as 1 by something, all right? I'm not excluding irrational numbers. You can write something like 1 by root 2. That is also fine. But whatever it is, you can write r less than 1 as 1 by something. Okay, it can be rational or irrational. So if you have a number of this format, 1 by something, and you raise it to an infinite power, then the numerator will remain 1, but the denominator will keep increasing. And in a fraction, if the denominator gets heavier, then the fraction will lower its value, right? You know, numerator constant, denominator increasing means fraction gets smaller. So the fraction will get smaller and smaller and smaller until it tends to 0. So 1 minus 0, that will be the final value at infinity. Okay. I don't know, you are very close, but
Yeah,
1 minus r to the power n is not going to 0. R to the power n
yeah.
is going to
I
0.
said it opposite. I said the
Yeah, yeah.
opposite.
Okay. So if r to the power n is going to 0, then 1 minus r to the power n will go to 1, because 1 minus 0 is 1 and a into 1 is 1. So a by 1 minus r. If r greater than 1, you cannot do this, because then r to the power n will keep increasing. All right. And it will be dne. Dne means does not exist. Okay. That means we cannot write it down. Writing down infinity is useless, because infinity can mean different things for everyone. Right. For us, maybe 100 crore is infinite, but for a money that is not infinite, right? That's pocket change. So that is the concept of infinity that we use here. And dne means does not exist. That means there is no fixed number for it. All right. So do a sum now. Let me provide it.
Sir, can you repeat what is DNA?
For dne means does not exist. Nothing else. It's a short form.
Oh, okay, okay.
uh, Try this.
Is it 10 terms?
Yes, 10 is correct. Others? Any doubts? If there are no doubts, then we will move on to the next sum. Otherwise, I will do it. Okay. Make sure. So
So what's the
everybody,
answer?
10, n equal to 10.
Okay, sir.
Okay. So you can just figure it out, right? R will be equal to half. So using that, you can do it. All right. So if R is equal to half, then you will use that other formula, right? You will use the mod R less than 1. Not mod R, but R less than 1. This formula. Right. So it will be 3 into 1 minus half to the power n. by 1 minus half. So this is basically half. So this will become 6. And then you can do the fractions and so on. Okay, it should not be a problem. All right. You will ultimately get 1 by 2 to the power n is equal to 3 by 3072. So you cancel 3 and 3072, you will get 1024. 1024 is 2 to the power 10. You know that. Okay. So n will be equal to 10. All right. Next, this is a bit tricky. So the next illustration, that is find 9 to the power 1/3 plus 9 to the power 1/9 plus mm, into 9 to the power 1 by 27 dot 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 equal to 3. Not find, but prove. Try this.
Since they are in multiplication, so the powers add up. 9 to the power 1 by 3 plus 1 by 3 square plus 1 by 3 cube. So I take a as 1 by 3, the ratio is 1 by 3, and I use that infinite uh, uh, GP some formula a by 1 by r, and I get like as half. So 9 to the power half is 3. So
Fine.
it's 2.
Others all clear? So in this problem, you use the properties of exponents. All right. So if you do that, you will get, so let's say LHS. So LHS is equal to 9 to the power 1/3 into 9 to the power 1/9 into 9 to the power 1 by 27 dot dot dot, which is equal to 9 to the power 1/3 plus 1/9 plus 1 by 27 plus dot dot dot. Now, if you have to write this one, you can just write it as let S equals to 1/3 plus 1/9 plus dot dot dot. That's it. Uh, for S, A is equal to 1/3, R is equal to 1/3, right? Okay. So sigma S will be equal to A by 1 minus R. So which is 1/3 by 1/3, sorry, 1 minus 1/3. So 1/3 by 2/3, half. So that means LHS will be equal to 9 to the power sigma S, which is 9 to the power half, which is 3, equal to RHS. All right, everyone. Any doubts? Let me know. This is how we will. This is how we will write it. Okay. All right. If it is fine, then we will do properties of GP. Now, what happens if you multiply or divide a GP by a fixed number? Is it still in GP?
Yes, sir.
Yes,
Multiplied and divided both.
yes.
Any
Yes, sir.
stipulations or any conditions there?
No, sir.
Hey, of course there is a condition. You cannot
Not
divide by
zero,
zero.
Zero.
not zero.
Yeah. So multiplication and division invariant. Invariant means it does not change. Uh, provided Not by 0. Right? What about addition and subtraction?
No,
It
sir.
will not remain.
No guarantee, right? Fine. Addition and subtraction may not be GP. All right. Next. Uh, what about raising to the power? If you raise GP to the power of something, then what happens? Each term is raised to the same power.
No, it's not in GP anymore.
That means what I'm saying is, let's say you have A1, sorry, let's say you have AR, AR square, dot, dot, dot. I'm raising everything to the same power. So A to the power M, AR to the power M, AR square to the power M, and so on. GP or not?
So it is still a GP, but the common ratio is different.
Correct. This is GP implies this is GP. What will be the common ratio?
R power n.
Of course. Here it is R. Here it is R power M. All right. Moving on. What about log? If AR square are in GP, let me move them. Log A, log AR, log AR square. What about these?
AP.
Very good. Why?
So because log operation transforms the subtraction into division, like log B
Hey,
minus log A is
এখানে
log B by
সাবট্রাকশন
A.
কোথায়? ডিভিশন কোথায় চলছে এখানে? Your answer is correct, but where is the division here?
Sir, multiplication into addition.
Yes, correct. Multiplication to addition. So you will get A plus R, A plus 2R, A plus 3R. That is AP. Okay. So that's it. That was correct. What about equal numbers? Are they in GP?
Yes, sir.
Yes, except 0.
R equal to 0, right? All right, fine.
R is equal to 1 will also work.
Oh, yeah, R is equal to 1 will also work. R is equal to 1 or fine, fine. Okay, so how would you select? Just like we did in AP, right? When we selected 3 terms, we went A minus D, A and A plus D. How would you select terms in GP?
A by R, A and AR.
That was for 2 terms. For 3 terms,
A by
how would you select 3 random terms in GP?
A by R, A, AR.
How would you select 4 terms?
A by R square, A by R, AR and AR square. No, those are not in GP.
No, A by R cube,
Hmm.
AR, uh, no, A by R cube, A by R, AR, AR cube.
Fine. This is it. Okay. So this is selecting terms. Selecting terms for a GP. All right. So this is how you will select the terms for a GP. Just like in AP, you had the beginning and the end terms to be adding up to be the same. In a GP, the beginning and the end term multiply to be the same. Okay, so if this is also a property that sometimes gets its uses. So if ar square sorry ar square dot ar to the power n minus 1 r in gp, then a into ar to the power n minus 1 is equal to ar into ar to the power n minus 2 dot, and all of them are equal to what? A square r to the power n minus 1. Agree?
Yes, sir.
So the product of equidistant terms from the beginning and the end are equal to the product of the first and last term. All right. We can use this property in sums, obviously. So try one.
Is R 2 by 5 or 5 by 2?
5 by 2 or 2 by 5?
Yes.
So what will be the terms?
5 by 2, 1, and no, 2 by 5, 1, 5 by 2, or uh,
The other way
2
around.
by 5, 1, 5 by 2. Yes.
Terms are the same, right? So you can write it in either
Yes.
ascending or descending. Yeah, fine. Everyone else, did you get this? So you will just get a quadratic equation and you have to solve it. So you will basically get r is equal to 2 by 5 comma 5 by 2. That means the terms will be 2 by 5, 1, 5 by 2. Okay. Or you will get 5 by 2, 1, and 2 by 5. Okay. It's just mirror images. All right.
Uh,
Yes. So
I
if
did
any
not.
if anyone does not get how this is solved, try it as homework. Even if you do not, ask me next day. All right. Let's go. Next problem. Try.
It's 1024.
Hmm. Fine. Others completed.
Is it 1024 by chance? Sir?
1024.
Yes, yes, all correct. 1024. Okay. Now we are almost done with the GP part. So therefore we will go on to geometric mean. So here you have first 5 terms product. Let, whoops. Let me just write the answer. So product will be equal to 1024. Okay, you can do this mentally also, because this the third term of a GP will only be 4 if the terms are 1, 2, and 4, right? So the next few terms should be 8 and 16. So multiply all of these, you'll get 1024. That is a simple way of doing it. Geometric mean. Okay, what is geometric mean? How do you define it? Hmm. Geometric mean between A and B is root AB. Where have you learned this before? You have done this in class 10. Where? Continued proportion, right? I hope you had ratio and proportion. So this is continued proportion, right? How is it calculated? Calculated such that A by G is equal to G by B. So that would mean G square equal to AB, which would mean G is equal to root AB. So this is the same as geometric mean. Okay. Now the same logic that we did with AP, how will you insert n geometric means? Okay. So try it. You did that thing right last time, so you can derive the formula. So insert n GMs between A and B. It'll work the same way.
b by a to the power 1 by n plus 1.
Let me check. B by A. Mm, yes, that will be R, right? So what will be A?
Okay, a.
Oh, sorry, what will be Tn?
T. Oh, wait. T.
Yeah, so N GMs means you have A and then N GM and then B, right? So B is the last term. So B will be equal to A into total N plus 2 terms, right? A to the power N plus 2 minus 1. This is how it should be, right? So
Yes.
that means R to the power N plus 1 will be equal to, okay, so R will be equal to B by A to the power 1 by N plus 1. Now we know. So any Tn plus 1 that is given by A into R to the power N minus 1. Now we have R. So here we are trying N plus 1, right? So this is N plus 1 minus 1. So this will be A into B by A to the power N by N plus 1, right? Because this N will be multiplied to there. And I think one of the A's will cancel, but let us not do that. Let us keep this form as it is. You can do the cancellations when there is the actual sum present. Okay, so this will be the formula. A into B by A to the power N by N plus 1. All right. I hope you understood where that N into N plus 1 came from. Okay, so N into N plus 1, we had it. And then we just multiplied. We had 1 by N plus 1 from here. And this is N plus 1 minus 1. So this cancelled and this N got multiplied here. Okay, so Tn plus 1, this is how you can insert N geometric means. So let us try. Okay. A few properties. A few properties. Let me discuss all of these. A few properties of geometric means. Geometric means are much more interesting than arithmetic means because arithmetic means are plain, vanilla, and simple. So what do we have here? So the product of n geometric means between a and b is equal to the nth power of the geometric mean of a and b. Right? So if you multiply all of these, what will you be getting? You will be getting G1, G2, all of the products is equal to the nth power of the geometric mean of A and B. All right. So how does this work out? You can figure out this proof very easily. You can try it from here. Okay. I think you can do this proof by mathematical induction. Okay. So just try with n equal to 1 first. So if you have n equal to 1, you will have G1 is equal to A by B to the power n by 2, right? Which is true because 1 by 2 G is equal to root AB. That is fine. Now assume that this is true for n and try to prove it for n plus 1. All right. You can do this. If not, then let me know. We'll do it next day. Proof by induction. All right. Next, the geometric mean of n positive numbers is, you can do that here. All right. Just because it is in power. Remember, for n arithmetic means, sorry, for n numbers in AP, we could not do. We had to do pairwise. But here you can do it together. All right. So this is a property. This will be useful. AG are the AM and GM between two positive numbers, and the numbers are A plus minus root over A square minus Z square. This is just a relation between those two. Okay. So you have A plus B by 2 and root AB. So how do you get A and B from here? A comma B from here. You just have to go for like A plus B whole square. That okay. So A, you find out A plus B is here. You find out A minus B. How will you find A minus B whole square? That is A plus B whole square minus 4AB. You do all of these, you will get it. Okay. Try the proof. So these will be your homeworks. Okay, I am giving you hints. Listen to the hints and then do the homework. I will send you over the entire notes starting from APs. Okay, I think I did not send it
I
last week.
didn't get the third point. Can you please re-explain the third
Okay,
point?
the third point says that if A and G are the arithmetic means and geometric means given, you will have to find the original numbers A and B. So
Okay,
A will be
okay.
what? A will be A plus B by 2 and G will be root over AB. So you have to figure out A and B from here. You can use algebra and do it.
Okay. Okay.
All right. Number 4, if A and G are respectively AM and GM between two positive numbers AB, then the quadratic equation has its roots. Well, this is also fine because you know, right? Sum of roots is B minus A. Use quadratic equation property. These are the 4 things that you will have to prove. Well, it's nothing known as have to, right? Online class. Even if you don't do, I will not know it. But make sure you try it on your own. And if you do have any trouble regarding these, let me know.